So how do we integrate functions which have as a quadratic denominator? So we want to look at that in particular. First two that we've got there are the difference of two squares. So a squared minus x squared minus a squared, which we could factorise, of course, and we could do it via partial fractions. Personally, I just memorise the answer. So it's 1 on 2a, the natural log, well, the first one's a plus x on a minus x, and the second one's x minus a on x plus a. Now, how do I remember that? Is, well, if it's a squared minus x squared, so you'll notice it's a squared minus x squared, then I start with the a. If it's x squared minus a squared, I start with the x. Now all I've got to remember is which one goes on top. Well, a squared minus x squared, so maybe we'll use the minus, and it's the minus x that's the key. It's finishing with minus x. Notice the integral, if you imagine writing the numerator first, then the denominator, you would finish with minus x. So it must be a plus x on a minus x. This one, it starts with x minus. Therefore, when I write down, I start with x minus. So x minus a on x plus a. That's how I tend to remember it. The next one then, sum of two squares, well, that's a standard integral, of course, inverse tan. So we shouldn't have any issues with that one. But then we could have all of those with a square root sign as well. Now, square root of a squared minus x squared, again, not a problem, because we know that to be inverse sine. The square root of x squared minus a squared, you'll remember when I looked at the non-standard integrals? This was one of them. So we get the log of x plus, and it's the square root sign's the same as what's in the integral. And the other one then becomes exactly the same, but this time it's the sum of the two squares under the square root sign, and we got the log of x plus the square root of x squared plus a squared. Now, as I think I mentioned to you, the interesting thing is these last two are no longer on the resource sheet. So it leads you to believe that, well, maybe they're not going to ask us ones that are like that, or they'd give us the standard integral in the question itself, or something like that, or they'll ask us to prove it, or that sort of thing. So x squared plus 4x plus 9, but we want to get it in the form of either sum of two squares, difference of two squares, so I'm going to have to complete the square in the denominator. So x plus half the coefficient is of course 2, but when I square that I get 4, so I need to add 5, so it's x squared plus a squared inverse tan. So that'll be 5, because the 5 on top, but then it's 1 on a, so 1 on root 5, inverse tan x on a, although in this case it's x plus 2 instead of x plus 2 on root 5, tidying that up, there's our answer. Square root x squared minus 4x plus 1. Oh, but hang on, there's also 3x on the top, not a constant. So this one I have to split into two integrals. The first integral, what I do is I create the derivative on top. Now the derivative of x squared minus 4x plus 1 is 2x minus 4. Can't change the question. I had 3x's, not 2x's. So I'll multiply it by 3 on 2. But what's that done to my constant? 3 on 2 times negative 4 is negative 6. I want to get to positive 2, so I now have to add another 8. Now the first integral, because I've set it up, so I've got the derivative on top, I've got du on root u. Well, we know that's going to be 2 root u. The second one, we'll have to complete the square and see which integral category that falls into. So if you don't see it, then all right, I'll do a substitution for the first one. U equals x squared minus 4x plus 1. The derivative is 2x minus 4. Oh, what do you know? That's on the top of the fraction. No coincidence. Of course, we created it that way. So that first one becomes du on root u. The second one, half the coefficient of x is negative 2. Square that, I get 4. But I want plus 1, so I've got to subtract 3. So it's x squared minus a squared. So the square root of x squared minus a squared, that was the log one, wasn't it? So I get 3 root u. I've still got to substitute back in for u, of course. But then 8 log, remember it was x, but in this case x minus 2, plus, and the square root stays the same as the square root. So I've got x squared minus 4x plus 1, sub the u back in. There's our answer for that particular integral. This time we're going to do something a little bit different. We're going to rationalise it but I'm actually going to rationalise the numerator, not the denominator. So I'll multiply by root x plus 3 on x plus 3. Doing that, I now end up with a nice quadratic denominator, in this case the square root of 6 minus x squared. But I've also got x in the numerator, so I'm going to have to, just like the last one, split it up into two integrals. The first integral, I want to create the derivative on top. The derivative would be minus 2x minus 1. Originally I had 1x, so I've got to multiply that by minus a half. What's that done to my constant? My constant's now plus a half. We want plus 3. So I have to add another 5 on 2. Now, why I put the 5 in the integral and the half outside the integral there, I don't know. I could have just as easily written 5 on 2 out the front. It doesn't really matter, I suppose. So the first one, du on root u. Now I'll say how often this comes up, du on root u. There it is again. So we know that's going to be 2 root u. The second one, I'm going to have to complete the square in the denominator. So again, if you didn't notice the du on root u, do your substitution. And there it is, du on root u. All right, this one's a little bit nastier. Half the coefficient of x. But notice I've got minus x squared. So you've got to be careful. So I know it's going to be minus all of that perfect square. Because when I expand out, I want to get minus x squared. That's minus x, half the coefficient of x. Now, normally, half the coefficient of x would be negative a half. But remember, when I expand out, I've now got this negative out the front. So I actually need plus a half in this one. Now, when I square that, I'm going to get a quarter, but it's going to be negative a quarter. I want 6. So 25 on 4, I've got to add back in. So I've got the 25 on 4. So it's now the form, the square root of a squared minus x squared. That's inverse sine, isn't it? Inverse sine. So all right, we end up with 5 on 2, inverse sine, 2 lots of x plus a half over 5, and there's my 2 root u as well. Sub back in for the u, but also let's tidy this fraction up. I mean, 2 outside of x plus a half, much needed just to write 2x plus 1 on that one. There's our answer. So, as I mentioned, the missing standard integrals. dx on a squared minus x squared. So if you see that, 1 on 2a, the log of a plus x on a minus x. Finishes with the x, finish with the x, the a minus x. If it's dx x squared minus a squared, begins with the x, so we'll begin with the x minus a. Other than that, they're identical, really. So we shall play with some quadratic denominators today.